Hi there, I'm Andrew, and today let's look at particle in a box fitting. On Moodle, there is a worksheet that includes data from particle in a box. It's step 2 in the procedure, taking data, and I've already imported all that data into this worksheet. Right here under raw data, here is the wavelength and the amplitude from each set of data. We got A2, B4, C6, D8. When you first open this, it's going to be a little bit bigger. You're going to see some noise right there, and you're going to make a couple little edits to it so that you can see the peaks a little bit easier. So A2, B4, C6, and D8, 4 sets of data. Next, we're going to take each set of data individually and fit them with a double peak fit. We have this new Gaussian amp um, tab in our data or in our worksheet, and we're going to click over there, and it looks really big and a little scary, but don't worry about it. We'll work through it together. We're going to first make a copy, mover copy, and we're going to create a copy. I'm going to move it right after the Gaussian amp, and then I'm going to rename it. So right click or control click, rename it to A2. And then I'll copy the A2 data into there. So I'm going to highlight A2, which I've already done, Control C or Command C. And I'm going to come over here to column L and M. I'm just going to right click, paste values. Or control click, paste special values in Windows. Also, we already have the error bar plugged in and copied all the way down. So now we got to scroll down and take a look at this data. It's already been zoomed in like you did with the raw data. And we have to estimate this bigger peak and this shoulder peak. And to do that, an easy way to do it is just hover the cursor over. And if the little tooltip doesn't show up right away, I usually click off and then I hover over it again. If that doesn't work, I select the graph and now I hover and there's a tooltip that pops up. And it's 424 and about 0.847, but I know it's going to come down just a little bit, so I'm just going to do 0.8. 0.8 and 424. Now for the width of that, I would come down about halfway, and so to about 0.4, and then come over to here for the taller peak, and I see 434 for my X. And so I would take that number and subtract my previous number I got. So up here, I would say that's going to be equal to 434 minus the value that I just had for my B. And so that's going to say my half height, half width is about 10. Now coming down and doing about the same thing, I would see about 0.4, and I know it's going to be down just a little bit, so, 400 for B, 0.4 for A, and it's a little bit wider, so I'm going to say 15. And so 400, and then, this is 0.4, and then 400, and then about 15 for width. Next, I'm going to go down and press the reset button, and that's going to copy these values over to here. We don't need to change anything for the fixed. We're going to come down between the two graphs and click the reset button. And that goes through and resets a few things. And now I see two little peaks. Those are the two peaks that I modeled. And then the overall fit adds up to those two peaks pretty good. But remember on our previous worksheet, we had some noise down below that we don't want to include in the fit. And some of these, they have a little bit of bumps here and there. And so we just want to find a little range right here around the peak. So I'm going to say 350 on this side and about 450 on that side. So 350 and 450. And if you were to look down here, it cuts it off right there. And if I was to cut off just a little bit more, like 430, see how it cut off right there? So I'm going to keep it at about 450 for now. Okay, every time you press reset, you'll have to put in those numbers again. And now I'm just going to go ahead and skip right to the fit times 10. And this takes a minute because it's copying, or it's going through and doing thousands of calculations, maybe even into the hundreds of thousands calculations. Now that looks pretty good. There's still a little bit of a pattern to it, and I'm just going to go ahead and hit fit 10 times again and see if it comes back just a little bit better. And let's see what it looks like. Yeah, so this part right here is noisier. That first little bit still has some data. Notice what happened when I did the fit. It actually made this peak shorter and this peak a little taller. And this part's taller because this height right here plus the height of the red peak right here adds up to be that part. And we're concerned with the larger wavelength, which has less energy, the first energy transition. So we would scroll back up here and we would say, well, that's going to be 424 times 424.773, etc. I'll just go ahead and copy that over to Control C, my sheet 1. I actually already have it there, 424.7731, and paste. And it was the same number, but minus just a couple digits at the end. So I'll show you how to do one more. I'm going to go to Gauss Amp again and move and copy. I'm going to create a copy and I'm going to move it right before. I already have 2 of them done. Okay, so there's Gauss Amp 2, and I'm going to rename that one to B4. Okay, now I'm going to come over here to the raw data and copy this data over. Controller Command C, and I'm going to come over here over to column L and paste. Then I'm going to scroll down, and now I do the same kind of estimation, and I would say it's about 520 and about 560. No, yep, about 520 and about 560. So 560, 520. The amplitude for the top was about 0.8. The one down below was about 0.3. The width was a little bit bigger than the first set, so I'm going to say this width is going to be 10, and the second one was going to be 20. And I'm going to go ahead and hit reset and see what happens to my data right there. And that looks pretty close, and I'm hoping that it will line up pretty well. But once again, I want to cut off my data, and so I want to say maybe 450 is not quite enough. I'm going to go ahead and cut it right off at 500 here. And on the other side, maybe 580. And it's okay that it cuts it off a little bit right here because there's actually some more. There's like a third peak down here. I'll show you on the next one. I actually fit it with 3 peaks. You only have to fit it with 2. But that will make it a little bit less symmetric, and that's going to give us some pattern in the residuals. All right, so it's fitting it, and that looks pretty good, but once again, there's a little pattern. This part's a little too tall. The rest of it's looking pretty good. It might be just a little too tall, then too short, then too tall again. I'm going to click fit 10 times one more time, and then I'm probably going to just take the number because it's not really changing much. It got just a little shifted, and I'm okay with that. The fit looks pretty good. Once again, it's a little shifted, and it would be a little it'd be a little bit better if I fit a third peak down here. The residuals would look a little bit nicer. So I'm going to go ahead and copy that value. Control C over to sheet 1, and it looks like I got about the same thing. Just the very last digits changed again. And I'm going to go to C6. Oops, I was only supposed to show you this part, not the actual data, or not the actual fit. And notice right here, I actually did fit a third peak. And these residuals still have a pattern, but if you were to notice over here, the standard deviation got smaller. And then, oh, I did it again. D8, this time I cut it off and only fit 2 peaks. And again, there's a little bit of a pattern. So I've already copied some rounded values over, or I've just typed them in. And now I need to convert those lambda from nanometers into meters. And so that's going to be equal to B2 times it by 1 e neg 9. And then I'll copy that down. But notice I also should probably convert that to a scientific. And so I'm going to come down there now at scientific notation. Next, we're going to take this number of bonds, and that's the conjugated bonds, conjugated carbon bonds, and we're going to multiply that number by 2 and then add 1. So we're going to say that's equal to that times 2 plus 1, and so we get a 3 and then so on, 5, 7, 9, Planck's constant, it's there in the books, 6.626 e to the negative 34. Negative 34. The mass of the electron is going to be 9.11 e to the negative 31, and the speed of light 3.0 e to the positive 8. And I'm just going to copy those three values down, double click, drag them down, and I get a value for box lengths and error in box lengths. And I'm just going to go ahead and copy those two sets over to my XZ fitting worksheet and paste values. Oops, I needed to have that down one. So I'm going to go back over to sheet 1 and insert a row, and I'm going to copy them again. Paste. And then for, instead of sodium like last week, this is just the C bonds, and it's going to automatically copy it over when I copy that. Control C and go over to my XZ fitting worksheet and paste that. All right, so over in the fit dialog, we want to have a 0, 0, and a 1 because there's going to be some n groups or an intercept on this set of data, and we also have a set of conjugated carbon bonds. Our residuals, for some strange reason, look a little bit weird. Not entirely sure what's going on down there. I think it may not. Oh, there we go. It didn't reset correctly, and now they look better. And then over here, we still got some data in from last week. I should have deleted that. Sorry about that. Now, our fitted value should be a little bit bigger than that, or showing, so I'm going to change that to scientific. And then what do we have for expected? Well, we don't know exactly what our expected n groups are, 2 times our n groups, but our expected value should be 1.34 plus 1.54 times 1E9 divided by 2. No, wait, just 1E9. And I forgot to put an equals in there. So we got 2.88 to the, that should have been 1E negative 9. 1E neg 9. 2.88 e to the negative 9. Actually, that should have been a, I'm stuck for a second. 134 and 154 e to the 9. E to the 10 should have been 1.3, 1.34 and 1.54 e to the 10. So e to the negative 10. That's an Armstrong. 1 e neg 10. And then I get 2.88 e to the negative 10 versus that to the negative 10. And so for a z-score, we're going to equal ABS, and we're going to do fitted value minus expected value and divided by the standard error. I need to convert that one also to a scientific. And I probably should have rounded that, so let's change that to a scientific, and then copy and value paste, and copy that down, change those to a scientific as well. And then my z-score gets just a little bit better. All right, that's it for today, except for our physics model being tested is now box length. And we can delete that as well. Your turn-in for today, you got to choose one of your fits, and you're going to be turning in this fit. You're going to be turning in the fit parameters for that, that fit, and you're also going to be turning in this XZ fitting sheet and the results over here. Those units aren't those units. You're going to be turning in this graph right here of your final results. And now that's it for today. Thanks for watching.